Okay, in this video we want to talk about how the computer stores a positive whole number. You'll recall in earlier videos we talked about how a computer stores capital letters. You turn on the 64 and 1, that's a capital A, and the 64 and 2 would be a capital B. Lowercase letters, 64, 32, and 1 was lowercase a, 64, 32, and 2 is lowercase b. The character 0, not the number 0, the character 0 was a 32 and 16. The character 1 was a 49, a 32, 16, and 1. The character 2 was a 50, 32, 16, and 2. But now we want to talk about how does the computer store a positive whole number. Okay, so basically in some program that we write, we'll talk about programs later, we're going to create a variable, a storage place in RAM, and this is RAM right up here. And we're going to create a variable called x. X is the name of our storage area, but it says it can only hold a byte. A byte is a whole number. Okay, well right now, if this x here looked like this, that would be 0. None of the bits are on. That's a 0. Okay, now if this bit was the only bit that was on, that's a 1. Because that is the 1 place, right? But only the 1 is on. And let's keep going. If you had the 1 and the 2 on, that's going to be the number 3. And if you had the 64 and 1 on, that's going to be the number 65. I know. So now I've really got you thinking about something, because I said 65 earlier was a capital A. Okay, well that leads us to the next question here. How important is a data type of a variable? If you say a variable is of type byte, it's only going to store numbers, whole numbers at that. So 64 and 1 is a 65. But if you said that you had a variable of type char and you had 65, that's going to be a capital A. So in a program, you may see somebody say char space letter semicolon. So here's an area, this is RAM here, this is all RAM. And here's a place in RAM, 1 byte big, called letter. Now because it's a char, it can hold characters on your keyboard. So now, right here, if you were to see this combination, 64 and 1, that's not, I mean, it is 65, but if it's only going to hold characters on your keyboard, the 64 and 1 now refers to capital A. So in programming, data types, which defined what our variables can hold, are very important. So if this was a char, letter is a variable of type char, 64 and 1 is capital A. Now, let's go back here. If in fact we have a byte, x, now if we had 64 and 1 on for a variable called x, which is of data type byte, 64 and 1 would be the number 65. So depending on your data type, sort of determines how the computer will interpret the bits that are on. But let's keep it simple. We're talking about how does the computer store a whole number. Assuming we have a variable of type x right here, you know, this is 0, this is 1, this is 3, a 2 and a 1 is a 3, this is a 65, and so forth. That's how the computer stores a whole number. Now, there is a little bit more to this story. And for right now, I'll just say to you, that's how you store whole numbers. But if we did have a variable of type byte, okay, just so you know, it's 1 byte big in main storage, but it has a range. And it can only really store from negative 128 to 0 to positive 127. That's its range. So if it stores something higher than 127, you can't use a byte. I'll get into that later on. I'm not worried about that right now. By the way, you say, Mr. N, how could we store 127? If you turn on all the bits here, but the last one. Okay, 64, 32, 16, 8, 4, 2, and 1. Hey guys, if you add them all up, you know what that is? That would be 127. 27. So that's how you store whole numbers.